Alright, so in this video we're going to be talking about similar figures. And you've heard the word similar before. It really just means two things that look the same, basically, or similar. In math, similar has a more specific meaning. So similar figures have the same shape, but they're not necessarily the same size. So if you look a little further down this paper here, you have two triangles. They pretty much look like they're the same basic shape, but they're not the same size. This one's smaller than the other one. So that's kind of what I'm talking about. And then similar figures in math have certain properties, and one of them is this. If two figures are similar, then their corresponding sides are proportional, and their corresponding angles are congruent. So let's go back and talk about what I mean. When I say corresponding sides, I'm talking about the sides that are in the same position or are matching. So here, like I might say that this side is in the same position as where the 2 is on this triangle, or the side here, the 2 inches here, is in the same position or kind of matches in the same spot as where the 4 is here. And then when I talk about their angles, I'm talking about the measure of their angle, like this measure and this measure, and being congruent, I really just mean they're equal. And so I wanted to kind of practice what those things mean really quick. So like if I'm talking about congruent angles, what I'm talking about is if you take two triangles like this. Can you see this? No, I'm not going to be able to see this. All right. So if what I did is these two sides here, these two triangles here are similar. And so that means that these sides are proportional. And by proportional, I mean they've been enlarged or they've been reduced the same amount. So you can kind of think of maybe an artist who is drawing a picture of a person. If they are drawing a picture from, let's say, a photograph, it's much smaller than the actual person, and maybe the picture they're drawing is more life-size. And then they're going to enlarge the eye, let's say, by 3 times the amount on the photo. Well, they want to make sure that they enlarge the nose the same amount, same proportion. Otherwise, you're going to have a really big eye and a really small nose, and that might look really weird. Okay, so that's what we mean by proportional sides, but the angles stay the same. So I cut a triangle that matches this one in the book here. And so I can see if I move it over to this bigger triangle, even though the sides are different lengths, these angles, this X and A, are in the same position, so they're corresponding angles. They match up. The angle measure is the same. And I can see the angle Y should correspond to angle B here. And you can see that these are also the same measure. And the angle Z here should correspond to angle C here. And you can see that it does. Those angles are exactly the same. And then again, just to practice a little more with what it means to be corresponding, here's a picture of a couple of triangles. Because you're going to have to be able to identify corresponding sides. So here it's showing you that angle M, this is the kind of the symbol for angle M they're talking about right here, corresponds to what in the second triangle over here? Well, M is in the same position as J, so this is going to correspond to angle J. And if I look at the next one, if I start with angle L, that's right here, this big angle right here, then in the first triangle, what angle is corresponding to L? Well, you can kind of see that angle O and angle L have the same position, they're the same measure. Same thing with the sides. Here I'm looking for side JL, so JL would be right here. Well, that's in the second triangle, so what side over here is in the same position? It would be MO. So they're going to be corresponding sides. If I look at MN, and for this next example here, MN, it's going to be in the same position as JK right here. So that's what we're talking about when we say corresponding angles and corresponding sides. So we go back to the notes here. The other part of this is that the ratio of those corresponding sides are not just proportional, but they're also known as the scale factor. And we'll talk more about scale factor in other videos, but it applies here as well. Okay, so if we get back to problem 1 here, and we're trying in this section to determine if these are similar or not. Well, one way to determine if two figures are truly similar is to decide whether or not their sides are proportional. And we've talked about proportions in other instances, but this is just another application of the proportion. So we always want to start with a word ratio. So in this case, I might say, all right, well, I'm going to compare the small triangle to the large triangle. So the small triangle, I'm going to draw my 4 boxes. In the small triangle, I'm going to start with this side here. Okay, so a 1. And then in the large triangle, what side corresponds to the 1? Well, 2, because it's in the same position. So I'm going to say 1 over 2. And I'm going to go back to my small triangle, and I can say, all right, I'm going to start with the 2 this time. What side corresponds to the 2? Well, the 4. So it's going to go here. If these figures are proportional, then they have to have the same cross products. That's one way to test it. Or I can use unit rates, or I can try scaling. But I'm going to use cross products because that's just most common. So I want to know, is 1 times 4 the same thing as 2 times 2? And 1 times 4 is 4, and 2 times 2 is 4. So yeah, these are similar because their cross products were the same. So we're going to try the same thing in this next part. And again, I might try to compare the small rectangle to the larger rectangle. So I'm going to start with boxes. Okay, and I'm just going to pick a side in the small triangle, or small rectangle, sorry. I'm going to circle it, so the 12. I'm going to start with the 12. And then I'm going to go over to the larger rectangle. What side corresponds to the 12? Well, looks like this was the long side in this one, so the long side in this one would be 6. And then I'm going to go back to my small rectangle. This side is a 3. What side over here corresponds to the 3? Well, the short side here would be the short side here would be corresponding, so this would be 4. All right, so once I've set up my proportion, I cross multiply. So is 6 times 3 the same thing as 12 times 4? Well, 6 times 3 is 18, and 12 times 4 is 48, so these are not equal. If their cross products are not the same, then these are not proportional and they're not similar. All right, so let's try this last one. I'm going to start again with the word ratio, so let's do small to large. Or just to be different, let's do, because there's more than one way to solve a proportion with similar figures, so I'm going to show you a different way. Instead of doing small to large this time, we're going to do side to side. So let's say the short side compared to the long side. So this time I'm going to look at my short side. So the short side here, this first triangle, is 5, compared to the long side in the second rectangle, or in the first rectangle, is 12. Okay, so I still want to make sure I'm matching up sides. So the short side here was 5. The short side here, now notice this one's kind of different because they rotated the rectangle. So the short side is not on the side, actually it's on the top. So the short side and the short side go on top, and then the long side needs to correspond to the long side, so that would be the 8, so they're both on bottom. It's not the only way to set up the proportion, it's just one of them. Check their cross products. 5 times 8 and 4 times 12. Are these going to be the same? 5 times 8 is 40. 4 times 12 is 48. These are not equal. So again, these are not similar. They may look similar, but if their sides are not congruent, or I'm sorry, if their sides are not proportional, then these are not similar. So that's how you determine whether or not two figures are similar.